We're the Drone 200 team with the members of our team listed here. We would like to start our presentation with this young man. This is a friend of mine named Dominic, and this was taken Dominic's senior year in high school back in 2018. This photo is significant because if you look in the background, you can see some charred branches on the trees, and kind of down low, you can see some remnants of a building. And this is significant because this was taken just 2 days after the Camp Fire in Paradise, California. So for those unfamiliar with the Camp Fire, this is the deadliest wildfire in California history. There were 85 civilian casualties. This area covered about 240 square miles, and all of this happened within roughly the first 4 hours of the fire. And upon investigating, CAL FIRE investigators determined that the cause of the fire was a PG&E owned and operated power line with a high likelihood of vegetation contact that caused the spark. So we think this devastation, devastation from this problem needs an elegant solution. And we think the solution is a combination of the availability of this new 5G environment. So thinking low latency, long range, position location, combined with the versatility and the remote operability of a drone. And so our goal would be to use drones like the ones depicted here to remotely conduct periodic electrical infrastructure inspections to find areas where vegetation may come in contact with a power line. And those drones would be positioned throughout the power line infrastructure network, and then would be remotely commanded to fly an automated pre-programmed inspection flight path. And our approach to this solution incorporates these 5 steps. And we feel that we're going to get into each one of these steps at length in the next few slides. But we feel if we are able to execute this properly and well, we would be able to prevent Dominic, pictured here, from ever again having to sift through the remains of his home.
As the first step, we used a database for wildfires that occurred in the United States from 1992 to 2015, which includes around 2 million wildfire records. As we are focusing on the fires that are caused by the power lines, we filter out the power line fires. In total, there are more than 1,000 records, as we can see in the diagram. After we got this graph, we prioritized the sites by 2 factors. The first one is the area has high risk of having fires, and the second is its rural area and needs remote control. As we can see, the green circle is the Yosemite area, and the blue one is the sequential national forest. As we're zooming in, we can get the longitude and latitude of that area. By using this information, we can spot the fire locations in this 2D aerial imagery. We can find out that vegetation management is necessary, but the potential problem is that we don't have a 3D imagery to see how exactly the potential position between power lines and plants, such as are there overlapping, touching, underneathing, or etc. Then our solution is to send out drones. In this video, we have algorithm to detect the distance between the power lines and the closest area of the plants. As we can know from left-hand side, we know we have a red center line, and as 50 inches both sides, they're considered as safe areas. If there are plants grow along the center line or within that specific area, we can alert that, and we can send alerting to the workers. They will come to cut it. Without the pandemic, we can go in directly to the sites and record the videos and run algorithm on that. But since currently we cannot go outside, that's why we use the pictures.
So this is our demo interface for controlling drones. This interface allows us to see the battery condition of each drone and pick which one to deploy for an automated investigation. We will also be able to see the recorded videos and alert history for each drone. Now we are showing a demo to simulate a short investigation task. Due to the pandemic, the simulation is done in my kitchen with stove fire. We are using Tello, a Wi-Fi connected and programmable drone. The drone is programmed to take an automated triangular path and stream its video real time to backend for image classification. In real application, we will scale up the flight path of the drone and make it fly along the power lines. We will also use 5G to make sure our streaming is real time and reliable. And this is how fire detection in the backend works. Our AI algorithm will run over the stream video and classify if each frame is safe. Like here, we detect a fire activity. The drone will then send an alert message to human. In real practice, we will also apply the AI detection algorithm for vegetation encroachment.
Our industry research showed that utility companies in California spend about $250 million a year on vegetation management. Assuming that we are able to provide monitoring, assessing, and maintenance services for vegetation, our expected revenue per mile is about $940. And 5G is key to the market. Assuming that one 5G-enabled drone can monitor about 5 miles of power lines, we expect about 53,000 subscriptions in California and about 1.1 million additional subscriptions in the US once 5G is fully operational. Our core offering is a fleet of 5G-enabled drones deployed over a personalized coverage area according to each regional customer's needs. On the analytical side, we are providing complementary fire detection and vegetation management analytics, as well as maintenance. Overall, our business model is a drone as a service model enabled by 5G. Our stakeholders include partnerships for amplified capabilities with satellites firms, vegetation maintenance experts, regulators such as the CPUC, and potential partnerships with 5G telecom companies. Our aim is to launch a pilot within PG&E's R&D division in cooperation with the CPUC first. Then we will incorporate vegetation management maintenance services in order to provide our first utility partner with a full service vegetation management offering by the end of this year. And after that, we look forward to expand throughout California and then to the rest of the US by late 2021.
So here is our learning path. Just a little bit of an overview of how we got from our initial idea, which was a voice-activated drone, to our final MVP. So after our first initial idea, we wanted to explore more of the benefits of 5G. And we decided to explore the applications of drones for industry use, for infrastructure inspection, transit, monitoring, or delivery. And our greatest pivot points came from advice that we got from industry professionals. After first speaking with Professor Kelly, she suggested that we use NAIP imagery to gather forestry data, and we floated the idea amongst ourselves that we might not even need a drone. But then we realized that large imagery and NAIP resolutions made it difficult to process the imagery, and we were unable to see power lines. So we decided that a drone was still needed. And then after consulting a drone specialist, we were able to purchase the Wi-Fi enabled low-cost drone that Looming presented. And because of our incorporation of drones and because of the resource limitations of that, we decided to identify fire risk areas so that we could focus our drone inspection to areas that need it most, which was presented by Zichi earlier. And from advice from other professionals, we decided to incorporate satellite imagery, fire warning detection, and vegetation management to create our final MVP. The drone industry is evolving thanks to 5G, and our project is just one of many applications that will be created once 5G is rolled out and accessible for everyone. Other examples, in addition to ours, is disaster detection for floods, earthquakes, etc. Even more infrastructure inspection, and drone delivery for consumer products. The most applicable one for today is our COVID-19 social distancing computer vision algorithm that can be seen here on this slide.